Okay, so the last transformation we're going to talk about is a little bit different than the first three. The first three were called rigid transformations because it did not change the size or shape of the image that we were either reflecting, rotating, or translating. Everything stayed the same size. Nothing got bigger or smaller, or nothing changed shape. The transformation you're going to see today, dilations, is going to change the size. So what a dilation is, it's just enlarging something or shrinking something. So again, we're not changing shapes. The new image is going to look very similar to the original. It is just going to be a bigger or a smaller version of the original. Okay, so we're going to change the size, same shape. What we're going to do is just doing some multiplying. If we multiply by a scale factor that is bigger than 1, we are going to be making something bigger. And if we're multiplying by a fraction or a decimal that's smaller than 1, then we are going to be making something smaller. Okay, dilated figures are similar. So again, they're going to look alike, but they're just going to be different sizes. Again, all we're going to do is just some simple multiplication. So we are going to focus on dilating just with the origin. So we are going to be either kind of stretching and pulling stuff away from the origin, or we're going to be kind of shrinking stuff towards the origin. So not only are these images going to get bigger or smaller, but they also will kind of stretch out or get further or closer to the origin as we dilate the entire graph about the origin. Okay, so this is really, really simple. This is actually probably the easiest one because you don't have to think like, should I change X or Y, or should I flip-flop, the points and make something negative. It is strictly, what am I multiplying by? What am I doing? Am I making this bigger, smaller, and multiplying both the X and the Y by that number? So for this example, it says triangle HJK has coordinates. H is 4, 8. J is negative 6, 4, and K is 0, negative 8. We want to dilate this triangle by a scale factor of -2 and write the new coordinates. So very, very simple. All we're doing is taking every single number, X and Y, and multiplying it by a -2. So that 4, 8 is going to become -8, -16. Okay, the -6, 4 is going to become a positive 12, 8. And then K, 0 times 2 is still going to be 0, and then -8 times -2 is going to be positive 16. This should be a -8. Mistake. Okay, so that it's very, like I said, this is probably the simplest one because you don't have to think, am I doing, going vertically? Am I going horizontally? Am I flip-flopping anything? Am I making anything negative? It is just straight, here's the number, here's the scale factor, multiply everything by that scale factor. Okay, looking at example 3, it says square A is smaller than square B. What's the scale factor that was used to dilate A to B? Now, just keeping in mind, A is bigger than B. So we're going from A, we're kind of reducing the size to B. So this scale factor has to be something smaller than 1. So it's definitely not C and it's definitely not D. Okay, to make something smaller, you have to have some sort of fraction or decimal that is smaller than 1. So we can do 1/7 or maybe it's 3/5. To decide exactly which one it is, we would just make that fraction. Okay, so one of the sides is 21 for B, one of the sides is 35 for A, and if we reduce that, I think we can both divide those by 7, so that would be 3/5. So this would be 3/5. Okay, but again, definitely not C and D because we are making something smaller, and in order to do that, we need a fraction. All right, last example. I want you to go ahead and pause the video here. Try this one on your own. So you're taking BRAT, that rectangle, which is actually already drawn for you, and the points are listed, and you are dilating this by a scale factor of 1/3. So you're going to take every number, you're going to kind of cut it into a third, multiply it by a third, and then so write the new coordinates and then also graph it. You will notice that when you graph it, again, this rectangle will get smaller, but not only is it going to shrink and get smaller, but it will also get pulled towards the origin as well. Okay, so again, pause the video, go ahead and unpause it when you think you have the correct coordinates and you have that new rectangle graphed. Okay, so here is what the new rectangle should look like. All right, so your new points should be, instead of negative 6, 6, should be negative 2, 2 for B. 3, 6 goes to 1, 2, 3, 3 goes to 1, 1, and then T from negative 6, 3 goes to negative 2, 1. Again, you can see that we have that same shape, but it's 3 times smaller. So we still have that rectangle. It's not like it's changing into a square or anything like that. We are shrinking it. It's making it smaller, and you can also notice that it did get closer to the origin. You can see that also that I put in orange those side links. Now, if you check those, and I actually counted the kind of units across and the units up and down. So across the top of the original, it was 9 units across. Across my new one is only 3. Notice it's a third smaller. Okay, 1/3 the size. Same thing up and down. Up and down that right-hand side from B to A, it was 3 units. My new one's only 1. Okay, again, kind of dividing that by 3 or making that 3 times as small. Okay, so again, super easy. We're just, whatever they tell you the scale factor is, you're multiplying everything by that scale factor. You're either stretching something out, making it bigger and stretching it away from the origin, or you're shrinking something down and kind of smushing it towards the origin. Okay, so go ahead and get these notes turned in, and then you do have a pretty short worksheet. I think it's only got 6 images on graphs that you have to either stretch and dilate, make bigger or smaller to complete for today.